Hey everyone, in this video we're just going to try to solve an interesting problem that you would never use in production, but it's the CCIE lab, and that's kind of the name of the game. So we have three routers here all in a row. All three of these routers have a loopback, so R1 is quad 1s, R2 is quad 2, R3 is quad 3s. And what we'll do is we'll head into R1 and we'll do a simple trace route to 3.3.3.3 with the source address of loopback 0. And as expected, it goes directly to 2 to 3, which is going to be normal behavior. However, we're going to pretend that we're on like a CCIE lab or something, and we're given this picture. And it says, we need to make our trace route look like this, where the traffic goes first hop to 2, then next hop back to 1. So let me put some arrows. Then back to 2. Then back to 1, then finally back to 2, back to 3. So we're going to create like a temporary loop in these few steps, and then the traffic will go over. So if you want, pause the video, try to come up with a solution on your own. Once you've done that, come back and I'll just jump right into how I have solved this problem. So let's head over to router 2, and what we're going to do is, unsurprisingly, some PBR, some policy-based routing. And specifically, what we'll do is we will use our route map for PBR to reference an access list. And this will be an extended access list, and I'm going to call it TTL, because that's what we're going to match on. We're going to match on the time to live. So we're going to permit IP any, and we can see here down at the bottom, TTL, match packets with a given TTL value. So I'll hit TTL, and now we have to pick the value, equal, greater than, less than. So what do we pick? Well, if we go back here and take a look at this, what we'll notice is we have the first packet here, which goes with a TTL of 1 because it's trace route, and that's how it works. So you send a TTL to 1, you get an unreachable. So it's TTL 1 here, and TTL 2 here, TTL 3 back to 2, TTL 4 comes back to 1, and then the final one is TTL 5, which goes to 2, but then continues on. So we want less than 5. We don't want less than 4 because then we miss this hop. So we definitely want less than 5. So let me head back over. TTL, we're going to do less than 5. Exit. Now let's do our route map. And I'll just call it PBR. Permit 10. Let's match that access list, which is actually IP address. TTL is the name of our access list. And then we'll set IP next hop. And the next hop is going to be router 1, which is 10.12.0.1. If you need to, show IP interface brief, exclude unassigned, 10.12.0.1. That's who we're going to send the traffic back to. Set next hop. And now we just go into the interface, which in my case is gig 01, that's facing router 1. And we will IP policy route map, whoops, if I can type today, PBR. And now let's head to R1 and let's do this same trace again. So we'll trace route 3333, source loopback 0. And sure enough, there we go. We have the traffic went to 2, came back to us, went to 2, came back to us, then finally went to 2 and 3. So fun little way to create a temporary routing loop using PBR for TTL. If you guys have any other cool ways to solve this problem, let me know. There's not many that I could think of, but that's it for today. Short little video. Hope you guys enjoyed it, and I'll see you on the next one.